Welcome to Chem Help ASAP. This is a third video in a series. It'll ultimately be 4 videos about having ChatGPT take my in-class tests. So I teach organic chemistry 2 typically, and that's where the tests are from. These are typically 2-hour tests. I see them as a 1-hour test, but students have 2 hours to work them. And for this particular test, the key topics are carbonyl chemistry like acetals and ketals, aldol reactions, and acid derivative chemistry. So I've gone over this in previous videos, but for these tests, I simply take the test, I get an image of the page, and I load that into ChatGPT. And then ChatGPT has access, at least visually, to the instructions as well as an image of what's on the test. So that's all I give ChatGPT, and I say, what's the answer? And it lets me know. So we'll go through the problems and we'll see how ChatGPT does on this particular test. Okay, here is the first question. This is a synthesis question. The students are asked to make this compound in the middle of the screen. And for all the carbons that appear in the molecule, they have to use one of these different starting materials for their carbon sources. You can see a little bit about me. When I look and use Word, I like to have the formatting characters on. I'm sorry if that's a distraction. I'm just old, so I kind of do that. Anyway, let's see how ChatGPT addresses this question. All right, this is question 1, and to the right we have ChatGPT's responses. This is not the full ChatGPT output. I truncated it a little bit to make it fit on the screen, but this is the gist of it. So if you notice, ChatGPT identifies a target, and that does indeed match the structure of the target compound. That's encouraging. And it says, let's begin with acetylene. Presumably, that's the 2 middle carbons in the structure. We can deprotonate that with sodamide and then treat it with benzyl bromide, it says. So that gives us a product that's interesting because, yes, we have the 2 central carbons, but we've added another carbon in between the 2 central carbons and the benzene ring. So now we're at a 3-carbon chain, and that is not what we'd expect. What's next? Well, ChatGPT wants to reduce the triple bond to give, again, 3 carbons coming off of our left benzene ring, and we're down kind of an odd side path. Note that step 3 is about making this structure, and this is not an allowed starter material. So a student would have to say, okay, well, I got to make this somehow from our allowed starting materials. So that's what ChatGPT does. It says, okay, we can go from benzene and do a Friedel-Crafts alkylation to get toluene, and then we could do a radical halogenation of toluene to get there. These reactions are things that my students would be familiar with, so this answer is reasonable for my students to see. And then how are we going to finish this up? Well, we're going to react benzyl bromide again with the thing that we made before. But notice, this is not the same as what we made before because ChatGPT has conveniently gotten rid of that extra carbon, which was going to be a real pain in the backside. But we're going to get that extra carbon again right here. And now ChatGPT gets very cagey, is this, this will be an SN2 or a Friedel-Crafts or something like that. It gets very nonspecific because it maybe on some level understands that there is a carbon count problem. But it magically says, ta-da, we get to the desired product. So anyway, this was a problem. When I wrote this question, I really kind of thought students would want to do like a Sonogashira coupling and, make some aromatic halide and do a coupling between acetylene, do it on one side, do it on the other, and then reduce. But this is what ChatGPT came up with. Let's go ahead and take a look at question number 2. Okay, question number 2. This is really all about tautomers, writing different tautomeric forms and then proposing additional tautomers. Then here's the additional tautomer. And then, picking which one is the most stable and then giving an explanation. So a little bit of mechanism, a little bit of structure, just kind of a mix within the context of what we studied, which is carbonyl chemistry. So ChatGPT is going to give us an answer to this, or try. Okay, again, ChatGPT is on the right. I'm not going to say that again because it's always going to be on the right. But okay, so what does it say? So propose tautomer C, and it gives some explanation that the tautomer might be shifting the enol tautomer further. And that means something, but it doesn't mean very much, and it doesn't help us generate a structure. It does then identify what is tautomer C. Now note that this structure doesn't have a ring. And we need a structure like A and B that has a ring. So there's some misreading of these structures. Let's say, so the carbonyl is position 1, 2, and 3. We can see that we have a 1, 2, and 3, but the phenyl group is not attached to nitrogen in position 3. So this is trouble. I'm going to guess that what this really means is this, which it isn't very helpful, but at least, we're missing a double bond. Presumably it would be right there. But it at least gets the idea to give an imine type resonance form, and there is a new imine right there. So I think that's where it's leading. We're going to work through this question, and we're going to, as we pick apart the answer, I think we're going to find out whether that's correct or not. Okay, so the mechanism. Brief outline. So we talked about an acid catalyzed tautomerization. I'm not going to do too much with this, but it starts with a protonation. Okay, to the carbonyl. So presumably we're starting with A. And we're going to protonate the carbonyl. And of course, I'd expect students to write out this mechanism in full. But we get to there, and that is followed by nucleophilic attack by the NH group. This is no longer a tautomerization. So this is a mess. But let's see what it says in the base catalyzed route. Deprotonation of the NH nitrogen. Okay, A does have an NH nitrogen, so that's a reasonable thing. And then electron shift. That's a little vague, but I think I know what it's saying. We're moving, doing a delocalization, showing a new resonance form, and that is setting up the imine. Okay, looking good. And then protonation of the carbonyl to form an OH. Okay, the OH and B, this is not going to be the OH and B, but it's going to be a different thing. So, but anyway, once we protonate this, we're going to get C. Okay, I can follow that. That wouldn't get much credit because I want to see it as a mechanism, but that's reasonable. So this is C, but we need an H there. Which is the most stable? Okay, we got to go to another page to see the insights that ChatGPT is going to share with us for this. All right, let's wrap up this question number 2. We know what C is based on the previous question. Which is the most stable tautomer? They say A. Okay, and why do they say A? They say the carbonyl is more stable than an enol. I can give that. What I'm really looking for is, there's no reason to redraw this. B has aromaticity. Now, I'll be honest, I can't remember exactly how I graded this because we actually made this compound in lab. And based on what solvent you use to take the NMR, you may see that A is the favored tautomer. So I can't remember exactly how I graded this. But when I wrote this question, I was thinking this, but I think I ended up being pretty lenient on the explanation and just made sure the explanation was consistent with the possible options for any structure they drew. Anyway, so maybe a little bit of broken question, but that's what ChatGPT did with it. All right, question 3. Question 3 is yet another synthesis question, and as the semester rolls on and the students learn more and more reactions, I tend to throw more and more of these synthesis type problems because they're open-ended. It gives the students a chance to approach problems in different ways because there are multiple correct answers to this kind of question. So I tend to lean into these questions a little bit more. So let's see how ChatGPT approached this. All right, ChatGPT states here's what your target compound is. It's 2-butanol, which unfortunately is incorrect because this is actually 3-pentanol. So we know that there are going to be some problems in this answer because it's going to probably be missing a compound. So step 1, form a 4-carbon alkyne using acetylene. Now, okay, that's kind of interesting because I do give it a 4-carbon starting material. I give it butanol, but it said, okay, let's put 2 pieces together. So it said, let's start with acetylene, apparently, deprotonate with sodamide, and then treat with ethyl bromide. Now, based on the rules, ChatGPT needs to make ethyl bromide. So presumably you take ethanol and treat it with HBr or PBr3 or something like that. But ChatGPT did not do that. It didn't make it starter material. But anyway, it gets to this product. So even though it needs 5 carbons, it thinks it needs 4 carbons, and it has its 4 carbons. And then step 2, hydration of the alkyne to give a ketone. And this is chemistry we've seen, hydration of alkynes. And this is more a Markovnikov type. It's not a simple Markovnikov. But with the mercury sulfate, you do get addition of the oxygen on the internal carbon. This gives 2-butanone. Okay, we're down the wrong path, but at least ChatGPT is stringing together reasonable reaction steps. And then step 3 is reduction of the ketone to give an alcohol. And it says you can use either sodium borohydride or lithium aluminum hydride. I'd like a little more specificity. I'd like something maybe that looks a little bit more like this. Treat with lithium aluminum hydride. And a second step of water for the protonation. And I don't know why I can't draw that properly, but anyway, this is in spirit correct, and that'll give the alcohol. Now, of course, the problem is it's the wrong alcohol. It's a carbon short. And since this question is really in a test, it's about aldol chemistry or carbonyl chemistry, I probably expect the students to oxidize propanol to that, and then maybe they would make this alkyl halide and turn that into a Grignard and then do an addition reaction or something like that. But anyway, this is, ChatGPT dropped it, and probably primarily because it put the wrong number of carbons in the chain. All right, here's question 4. Question 4 is really, it's an acid derivative question, conversion of an amide and hydrolysis into a carboxylic acid. Carboxylic acid. Okay, you don't need to see that because it's not helpful. But anyway, this is acid derivative chemistry, and then you have to make a little bit of analysis of the mechanism that's drawn. So we get a little mechanism, and then we get a little put in words why you like it. Okay, so that's the question. Okay, here's question 4 for ChatGPT. So we need this mechanism, and so what's it say? It says hydroxide. That's great. Hydroxide attacks the carbonyl. Good. To give a tetrahedral intermediate. That's perfect. Now, ChatGPT does this in text form, and of course, I'd want students to write this out, show curved arrow notation in a clear manner. You can ask ChatGPT to do that, but in my experience, it doesn't have the ability to do that. So, but anyway, it does give, the words are consistent with what I'd expect to see. So there's our tetrahedral intermediate. Collapse of the tetrahedral intermediate, expelling the amide nitrogen as a leaving group, and it even says, hey, this is a problem, but this is what we're going to have to draw. So that would give this as the product. And deprotonation of the carboxylic acid, the acid. Now, this is a little, I'm not totally clear on this because the fact is in base you would not get this carboxylic acid. I was interested in making the students write out this step because I want them to critically analyze this. But this is a little sketchy. Yes, this would get deprotonated and this would be protonated, not having, as I've shown in the products, both of them protonated. But anyway, everything that ChatGPT writes is fine. So that's a correct answer. So which step is the most difficult step? So that's step 1, and that is step 2. And they should number each step. And the difficult step is step number 2. And explanation, it's a bad leaving group. The N minus is a bad leaving group. Hey, perfect. That's fine. So really, although ChatGPT didn't provide the pictures that I wanted, because I'm not sure it's capable of doing that, this was a very reasonable answer. So, well done, ChatGPT. Okay, the last question in the test was a full one-page question. It's a 3-page test, and the last page is just roadmap questions like this. And so I can't fit the whole page on the screen. So here is the top half. So this is question 5A. All right, question 5. We're going to end this with question 5 because question 5 fills up an entire page. So I'm just showing you the top of the page, and therefore this is 5A. And this page is a bunch of roadmap questions. And notice that we have triphenylphosphine in here. That kind of screams Wittig reagent or Wittig reaction. So that's what we're going to see here. And ChatGPT recognizes that. Now, the key thing for the Wittig is you have to recognize that this is the piece that gets added to your triphenylphosphine. So what does ChatGPT put in box 1? It puts 1 bromo, 2 phenyl ethane. So it has lost track of that particular methyl group. And we've seen ChatGPT do this before. Of course, I've seen students do this before. It's a really common mistake, and ChatGPT does it too. Box 2 is the reaction product from these 2 reagents, and it's going to be a phosphonium ion. And ChatGPT is all over that. And it gives that as the structure, even includes the bromide counterion. Very nice. It's missing a methyl group, but it's all self-consistent. The box below the first box, and that's right here on the left, lower left, is 3-methyl-2-butanone. So 2-butanone with a 3-methyl. Now, that's incorrect because we just need to add these 3 carbons. We need a 3-carbon group in here. It should be acetone. So again, counting carbons is a challenge. And for the final product, so I've set this up, do an addition of HCl, and that's going to give the chloride in that position. And then we'll do an intramolecular Friedel-Crafts alkylation. Students can't stand intramolecular processes, but it's simply something we've seen before. And ChatGPT knows this is going to be an alkylated hydrocarbon that matches the Friedel-Crafts addition product. Oh, okay, it's pretty good. It probably saw the aluminum trichloride and recognized that that's a pattern match. Now, unfortunately, as much as I like this question, I screwed it up because that's not going to be our proper formula. So this is going to be a 6-membered ring, and it's going to be fused to a 5-membered ring. And let's get our double bonds in there. We're going to have a methyl group there, and we're going to have methyl groups here. And if you count it up, we have 6, 7, 8, 9, 10, 11, 12. C12 is just fine. But our hydrogen count, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have too many hydrogens in here. Now, when I do this in a class, unfortunately, I have to I typically throw out that part of the question. But I do enjoy seeing how students handle when information doesn't match up. And, some students will know that this has got to be the answer, and they might leave a comment, "Hey, knucklehead, yeah, I think you miscounted on here." So, and then it confuses some students. But anyway, it is interesting to see the outcome. You can see what ChatGPT said. It's got to be something like an alkylated product, and it was correct. Of course, it didn't propose a structure because it's not going to get a structure that matches that formula. Okay, last question. This is question 5B because this is the bottom half of the page with the roadmap questions, and so the instructions are cut off. But let's walk through these. Okay, here's what ChatGPT says. So let's number these boxes. This is 1, 2, 3, and 4, and this is row number 3. I'm going to leave that out special. So for box 1, ChatGPT recognizes that we need to add this methyl group, and so it says to use a Grignard That's great. The problem is that's only part of what's happened. We also have this ethyl group. So you really needed another step in there where first you do something like this, LDA and ethyl bromide, and then you do the Grignard addition. So that's, semi-correct, but it did miss some carbons. It missed these 2 carbons right here. And then for box 2, it says 3-methyl cyclopentene as the product. And it does recognize that this is probably going to be some kind of E1 reaction, but again, we've lost some carbons along the way. So it did get the alkene, but the rest of the ring is not fully intact. Okay, so let's go down to the next line, box number 3. So we're going to react this with thionyl chloride to make the acid chloride. That's great. And then we're making an amide. So it then treats it with an amine, but it does pyrrolidine, and really we ought to have cyclopentylamine. So my guess is there's some amount of pattern recognition, and ChatGPT has seen a whole lot more pyrrolidine as a 5-membered ring than cyclopentylamine, and so pyrrolidine took the crown for that. But it's supposed to be cyclopentylamine. And then box 4 is indeed going to be a lithium aluminum hydride reduction. I'm pretty strict with my students to write lithium aluminum hydride. And as a second step, you need that water in the workup. So, but anyway, this is a lot of people would say it's a totally legit answer. It's more of a style issue than really strictly right and wrong. Okay, now let's talk about row 3, because row 3 didn't go as well. So the starter material, it says, is phthalic anhydride derivative. So this derivative, it knows it doesn't know what it's talking about. Or maybe it doesn't know, but it has a sense that something's amiss. This is an acetal. Acetal or ketal, depending on what textbook you look at. And so anyway, so step 1, it wants to treat this with ammonium hydroxide or a primary amine. It has no confidence in its answer here. What I'm really looking for is, and the rest is no better. So what I really want to see is just do some acid and water here, hydrolyze that ketal. Not the best picture, but restore your ketone. And then we spent a decent amount of time talking about the idea of introducing a nucleophile alpha to a carbonyl. So you need to do an alpha halogenation and then treat with something like sodium cyanide to make that structure. So, but ChatGPT completely bombed that, in part because it couldn't figure out what the heck this was. And if it can't figure out what that is, it's going to be really hard to figure out how to get to the final product. That is the end of test number 3. How did ChatGPT do? Not that great. So, it's no surprise that as you get towards the end of the class, the material is more complicated, and that is a strain for ChatGPT. There's probably less material out there for ChatGPT to train on to try to process some of these questions. But regardless, it was a little bit of hit and mostly miss, which is not surprising. Well, thank you so much for your attention. I hope you enjoyed the video. If you did, please leave a like or subscribe. Take care.